itself and 1. But 1 is not a prime number, just by definition. There are things called twin primes. Twin primes are a novelty. I'm not necessarily going to require that you know them. Does anyone know what a twin prime is? Twin primes are primes that are separated by the smallest possible prime division, and that is 2. So an example of actually, I don't like how this is written, so I'm going to rewrite this. Twin primes are prime numbers separated by 2. By 2 numbers. So an example of this, the smallest example of twin primes is what? Sorry? 3 and 5. 5 and 7 would be the next one. But they actually form a triplet, a prime triplet. 3, 5, and 7 are all prime. So they're a triplet of numbers. They're a novelty. They show up and you're like, oh, that's kind of cool, but we don't actually do anything with them. Factors we've already talked about. Again, I probably should have done this lesson before I did the previous lesson, but whatever, that's fine. You guys are great. Prime numbers are the numbers that multiply to give a specific value. So for example, if our value is 6, the factors of 6 are the numbers that multiply to give us 6. So factors of 6 are 1, 2, 3, and 6, because 1 times 6 is 6, and 2 times 3 is 6. The factors of 20 are 1, 2, 4. Someone's rattling them off. Is that Carolyn? Quietly rattling them off very fast. Let's further back. It's Rebecca. Keep going, Rebecca. 1, 2, 4. 5, 10, and 20. Because 1 times 20 equals 20, 4 times 5 equals 20, and 2 times 10 equals 20. And typically what you want to do is you want to pair your factors if you're factoring things so you don't miss any. So 45, the factors of 45 are 1 and 45. Next one. 3 and 15. And when you find a pair that are really close together, there won't be anything between them. So I've got, we can look here to make sure we've got all of them. We've got 1, 3, and 5. There's no 2, there's no 4, because 45 is odd. And you've got down here, we've got 5 and 9. There's nothing between 5 and 9 that multiplies into 45, so we've got them all. We're done. We've met in the middle, and we've got all the small ones. Or something like 36. 36 could be a little bit more difficult, because there's more. What are the factors of 36? 1 and 36. 2 and 2 and 18. 3 and 4 and. Is there anything between 4 and 9 that multiplies into 36? 6 and itself. Cool. And if the number we have is a perfect square, once we find that middle number, then we're set. There's nothing else to do. So prime factors, we've already kind of talked about those. These are the prime numbers multiplied to give a specific value. And we have the technique that you guys have learned in the past that we brought back up when we were doing square roots, are the factor trees. Using a factor tree can give us all the prime factors. So write the following numbers as the product of prime factors. We're going to do that. We're going to use a factor tree. There are other ways to do this. How else have you learned how to do this? Using factor trees is one way. I'm only pausing here because there's other techniques that my students in the past have told me that they've seen. Okay, nothing? That's fine. Let's go. Then you have to use a factor tree. 20 is what times what? Sorry? 2 and 10. You could also say it's 4 and 5. It doesn't matter what your first pairing is. The rest of the procedure falls out the same way. 2 times 10 is 20. 10 is 5 times 2. And I've got my prime. How do I know when I've got my prime factors? Yeah, when I can't break it up any further. Nothing times something else is 2, and nothing times something else is 5, other than 1 and itself, like 1 and 5 or 1 and 2, right? So how we say this is 20 is 2 times 2 times 5, or we can write, we call these the prime factorizations. Now we're doing something a little bit different with the prime factorizations. What we wanted to do before was to simplify roots. This is just in general writing the prime factorization for a value. I can rewrite 2 times 2 times 5 as 2 squared times 5, where I have 2 2's and a 5. Prime factorization of 35 is? Yeah, there's only one. 5 and 7. So 35 is going to be 5 times 7. And 90, sorry? Okay, 2 and 45. Can we keep going? Okay, so do it. Keep going. This is 5 and 9. And 3 and 3. So then the prime factorization of 90 is what? How would I write it? I mean, we just want the primes. Times 2 times 5. And typically how we write them is in order of like increasing value. So, I mean, you don't have to because you can multiply in any order you want, but typically how we write these things is 2 times 3 squared times 5. So this is a prime factorization. Cool? Comments, questions, concerns? No issues. This should be review. This is review, yes? Okay, cool. Fantastic. If it is review, what I want you to do is I'm going to give you, I don't know how much time I want to give you. I'm going to do something else today too. 2 relatively short. Okay, so I'll give you an option. I'll give you a choice. You can either take some time right now to work on these questions. It's quick. I'll probably give you, I don't know, 10 minutes to do it. You'll probably all get done. Or I can do both lessons, give you all the homework, and then tell you to go nuts. Hands up for both lessons, all the homework, and going nuts. Hands up for I want to take 10 minutes to finish this, and then we'll do the next lesson. Okay, lots of you didn't vote. Hands up for option 1. Both lessons, and I want hands up. This is hands up. This is I have a fear of commitment. Hands up for both lessons, and then all the homework, and we just go. 1, 2, 3. 1, 2, 3, 4. Okay, hands up right now. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 of you. Hands up for option 2. I want 10 minutes to work on this now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dang it, it's even. Well, tie goes to the easier option, so the easier option is to give you 10 minutes to finish this now. Go. You have 10 minutes. Go. Block B. Okay, here's what you should have come up with. Something looks like this. You didn't necessarily have to write these lists exactly the same way I did, but you need to have them all. Comments, questions, concerns. Comments, questions, concerns? We're good. Okay, fantastic. Flip the page. I'm going to introduce you to another mathematical object. An operator. Hands up if you've seen absolute values before. Where, Presley? What do you mean here? Oh, in this booklet. You were flipping through the booklet, you saw it. Fantastic. So, there is an operator in mathematics. Actually, there are many operators in mathematics, but the one that we're going to look at today is what's called the absolute value operator. And you'll see what it does here in a sec. So, we'll start by using words to describe the locations of 3 and -3 on the number line. So, where's 3? Where's -3? Talk to me. That's not sufficient. I cannot see your page. No, don't show me your page. I want you to, using words, describe to me where 3 and -3 are. Okay, let's start with 3. From 0, three places to the right. Okay. How about the other one? So how did you know whether to go left or right? Like, that's a simple question. And you're laughing, like, oh, I just knew. But how did we know? Danny, you have a thought?
Like when you add numbers, it gets bigger to the right. So that's where the bigger numbers are. I don't know, like, because you have 0 and positive and, like,
So inherently,
subtraction and addition.
kind of, yeah, kind of, sort of. How is a number line typically arranged? This way. Yes, okay, it does go left and right, yeah. And from 0, the left side of 0 is your negatives. Your right side of 0 is. And to move left means you're moving in a, what did I say? Did I say moving right? To move left means you're moving in a negative direction. And to move right means you're moving in a positive direction. So this piece right here, and I'm going to explicitly put it on this side, these things give direction. So whether our value is, so if we're looking at a number, if it's positive or negative, it tells us which way to go. So then what happens to the other piece? What does the 3 do in this case? Yeah, Rebecca? Yeah, how far to go? So the breaking up these two pieces has use. There is something useful about not caring what the direction is. Like positive and negative, that just gives you a direction. We want to be able to care less about the direction and just know how big something is. The language we use here, the how far to go, we have a language for that. We say that this is the size of something. Sometimes we call it the magnitude. Typically that word magnitude, what context do you know this word magnitude? Have you heard this word magnitude before?
Yeah.
Where? Sorry? The earth. What about the earth? But where have you heard of this? Well, it is size, yes, but where have you heard this term magnitude? Just science. Okay, so we're getting closer. Science involving the Earth. Okay, maybe a little bit closer. Keep going. Earth. No. There you go. Earthquakes. Typically when we think of magnitude, and that's the first thing my Physics 11 said, they said, so like magnitude, oh yeah, like how big an earthquake is. Like, well, that's typically where we think of these things, but it's not just, magnitude isn't connected to earthquakes, it's connected to the idea of how big something is. So there is a mathematical operator that we give a value to, and it just returns to us how big something is. And it seems relatively simple. And that's because it is, but we're going to overthink it, and it's going to go horribly wrong, but that's okay. So the idea of magnitude is where we get the concept of an absolute value. How big something is what the absolute value of something is. The absolute value of any real number, let's say any real number x, we're bringing letters in now to algebra, it's going to be great, is written using the following notation. We write it as x between two big bars, vertical bars, and this is read as the absolute, we say that this is the absolute value of x. If you're doing bed mass, absolute value work like brackets in bed mass. Except there are brackets that actually do something. They don't just hold, they alter what's inside them. And what they tell you is how far away from 0, in this case we're talking about x, we want to know how far away from 0 x is. We don't care which way. All it returns to us is the magnitude piece. So a really simple way to think about this is if it's positive, we just get the number back. If it's negative, it drops to negative and we just get the number back. Something that some of you have been doing for years, just spontaneously dropping negatives. Now we have an operator to do that. If some of you feel called out right now, you should. Here we go. Solve a couple examples. So if I have the absolute value of 6, is how I would say that. The absolute value of 6 is? Cool. How about the absolute value of negative 6? That's just 6. Because negative 6 and 6 are both 6 away from 0. Let's make it funner. By funner, I mean more fun. Negative 1 plus 3. Absolute values function like brackets, so I would get 2. I would do the negative 1 plus 3 is positive 2, and then the absolute value of 2 is 2. How about this? Absolute value of negative 5 plus 2. How would I do that? Negative 5 plus 2 is? Okay, so how we'd write, if we're going to stage it, how I'd write it is negative 5 plus 2, that's negative 3, and the absolute values will stay on the outside because we haven't used them yet. And then the absolute value of negative 3 is 3. So here's how we would show our steps. What if I have something like this? Ooh. What's it asking? So this is now where we have to look at the context of the question. How it's written matters. How they're connected matters. So I got 7, take away. So if this is just -4, then what do these two numbers, or these two lines represent? Using absolute values. Okay, so this, someone said, is this a 1? Is this 7 minus 1 minus -4? But then I've got something that looks bigger than a 1 here, and I've got a pair of absolute values. Absolute values are not written like this. A single absolute value bar must be matched on the other side by another absolute value bar, and there has to be a value in between them. So these two form a pair of absolute values, and these two form a pair of absolute values. So you have to learn how to read comfortably this kind of notation. So then if we're going to do this, we're going to approach this thing similar to bed mass. Anyone want to take a stab? Yes, Harwin. Careful. Absolute values function like brackets. Do I have something inside the absolute values? Then I have to do that first. Now I'm not just dropping brackets. Now I actually have to do the absolute values. What is the absolute value of -4? It's 4. So this is going to become -3 absolute value 7 minus the absolute value of -4 is 4. Close the absolute value plus 4. 7 minus 4 is? So this is going to become -3 times the absolute value of 3 plus 4. Okay, what's next? The absolute values aren't just brackets. The absolute values are an operator. But they function in the place of brackets. So I actually have to do this piece first. What's the absolute value of 3? 3. So this is going to become -3 times 3 plus 4. It's going to be -9 plus 4, which is -5, and we're done. Okay? So it's a set of brackets that actually does something. And you have to be careful to match them up properly. Comments, questions, concerns? Cool. Then let's practice. And I've got a lot of practice for you to do. It's fun.
What was the answer?
-5. The answer there is -5. Okay, so here's what I want you to do. On this page, you're going to walk through with me here. I want you to do all of these. I want you to do all of the, do I want you to do all of those? Those are easy. You can skip this one. We'll leave it for extra practice if you want. This one gets, does it get more interesting? No, we'll skip this one. Leave it blank for extra practice if you want. And then we get to Crazy Town. Where there are 85 questions. There's 85 questions in there, and here's what I want you to do. We're going to make it interesting for you. I want you to do the primes. I want you to do the prime numbered questions to connect it to the first lesson that we did today. Do the prime numbered questions. So would you do question number 1? No, you do 2, and then you do, and then you do, and then you do, and then you do. No, because 9 is 3 times 3. Okay, you got it. So you're gonna basically now you got to figure out all the primes between 1 and 85. Good luck. Have at her. I want you to do the prime questions on all of the next couple pages between 1 and 85. And if you look, prime, there's not actually that many prime factors between 1 and 85. The answers are at the back here. Bam.
Why would you tell us?
Because I want you to check your work.
But like, what if people cheat?
I don't check homework. So ultimately, what you'd be doing is writing down answers to something that I'm not going to check, which means that you still don't know how to do it, so that when I give you a test, I'm going to crucify you. So that's why I provide the answers to you, so that you can actually, because all I show you is the answers. If you can't figure out how to get that answer, that's where you come to class the next day and you're like, hey, Mr. Rudolph, I couldn't do prime number blah, 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 79. And then I would then show you how to do it. Okay, giver.